This is a very tough question which tests you on your understanding of potential and potential difference. So we can see that there are four resistors connected in parallel. Let's just label them R1, R2, R3, and R4. They are connected to a power supply of 12 volts. So I will just add in the 12 volts battery connection. Now, if we look at R1 and R2, we noted that these two resistors share the EMF of 12 volts equally because they have the same resistance, 1000 ohm and 1000 ohm. So the potential difference across R1 is 6 volts. Note how I've written the notation for potential difference. I put a triangle to mean difference in potential. This will come in useful later on. Now, what does a potential difference of 6 volts mean? It means that when the charges flow past R1, the potential decrease by 6 volts. For every 1 coulomb worth of charges that flow past R1, 6 joules of potential energy will be given to R1 for it to operate. That's the meaning of potential difference. We then trace back the path of current from the battery. When the charges first flow out of the battery, immediately it would have received potential energy from the battery. So this charges carries this potential energy and they move around the circuit and they pass this potential energy to the components. So if you look at the pop-up, the most recent pop-up, at that point, if you were to measure the potential value, you will get 12 volts. This means that if at that point you take out 1 coulomb worth of charges, then this coulomb worth of charges would have contained 12 joules of potential energy because the units for volts is joules per coulomb. If we move along the path of the current down the path, let's say I choose this point to analyze and to take out 1 coulomb worth of charges, the potential energy will still be 12 joules for every coulomb of charge, which means the potential is 12 volts. The charges haven't lost or transferred this potential energy away yet. Now, after this point, the charges will then flow past R1, and from what we analyzed just now, these charges will decrease its potential energy by 6 joules for every 1 coulomb worth of charges. So what will be the remaining potential at point X? If initially, before the charges pass through R1, the potential is 12 volts, and passing through R1 means a decrease by 6 volts, it must mean that the potential remaining at point X is only 6 volts. Again, 6 volts potential means if I were to fish out 1 coulomb worth of charges there, the potential energy contained by these charges will be 6 joules for every 1 coulomb. We can do the same analysis for R3 and R4, and since the values of the resistance are all the same, identical, I will skip the earlier analysis and immediately the potential Vy at Y is also 6 volts. We can now solve part A, where it asks what is the potential difference between point X and point Y. So we have established that the potential at X is 6 volts and the potential at Y is also 6 volts. Therefore, the difference between these two potential is 0 volts. Part 2, what happens if you connect a wire across X and Y, will there be current flowing through this new wire? The answer is no, actually, for this case, because current flows from a higher potential to a lower potential. And in this case, X and Y has the same potential of 6 volts. There is no difference in potential, and therefore no current will flow. In part B, we will apply the same analysis as in part A. And we noted that the resistors are now of different resistance. So we will have to use potential divider equation somewhere in our analysis. Same thing, let us start by labeling the resistors R1, R2, R3, and R4. And they are connected to a power source of 12 volts. So we'll look at R1 and R2, and we'll apply the PD equation to find the potential difference across R1. So putting in the resistance value, we got a voltage value of 4 volts. Again, a potential difference across the resistor R1 of 4 volts means that as charges go past this resistor, there is a decrease in the potential energy of these charges. Every 1 coulomb worth of charge will give 4 joules of potential energy to the resistor for it to operate. So again, when we start tracing the path of the charges, they will start off receiving and having the full amount of potential energy from the battery. So the potential at this point is 12 volts, or in other words, every 1 coulomb worth of charges that you fish out at this point should contain 12 joules of potential energy. The same thing applies to this point because potential energy has not been transferred from the charges to any components yet. And once the charges flow past resistor 1, we calculated just now that there is a decrease in potential of 4 volts. Therefore, initially, before they pass through R1, they have 12 volts of potential, and 12 volts drop by 4 volts. This means that the potential at X will only be 8 volts. In other words, at point X, if I take out 1 coulomb worth of charges and I measure the potential energy, there will only be 8 joules remaining. 4 joules has already been transferred and converted to the resistor R1 for it to operate. We can do the same analysis on R3 and R4. So same thing, we apply the PD equation on R3, we will get voltage or potential difference of 8 volts. This means that 8 joules of potential energy will be given by every 1 coulomb worth of charges to R3 for it to work. And before the charges go past R3, the charges will have the full amount of potential energy, which is 12 volts potential. And if you go past R3 and you see a drop by 8 volts, this means that at point Y, the potential is only 4 volts remaining. And we are therefore ready to solve the 2 questions. The potential difference between point X and Y, we have established that the potential at X is 8 volts, potential at Y is 4 volts. The potential difference, you just take the difference between these 2 potential values, you will get the answer of 4 volts. And therefore, should you connect a wire across X and Y, there will be a current flow from the higher potential, which is X, to the lower potential, which is Y.